Design tips for sheet metal bending. Bending is one of the most commonly used processes when forming sheet metal parts. The costs and quality depend on various factors, including setup costs, material costs, and design complexity. To ensure a trouble-free bend and to avoid deformation, we recommend following certain design tips for every type of sheet metal part feature. Walls. Uniform thickness. Parts are usually fabricated from a single sheet of metal, so they should have a uniform wall thickness. Bends, radius and orientation. Keep a minimum bend radius to prevent parts from fracturing or distorting. We typically recommend that the smallest bend radius should at least be equal to the sheet thickness. However, there are also various reference tables that show minimum bend radii for different materials and part thicknesses. Keeping the bend radius consistent makes the part cost-effective, as you can use the same tool to bend it. Keeping bends in the same plane in one direction also helps to save time and money by preventing part reorientation, especially for parts with complex bending. Bends. Placing bends next to each other. You should avoid successive bends except when absolutely necessary. A common problem for successive bends is the difficulty of fitting the bent parts on the die. However, when unavoidable, the intermediate part should be longer than the flanges. Bends. Cut reliefs. When a bend is made close to an edge, the material may tear unless bend relief is given. The width of the relief cuts should at least be equal to the material thickness, and the length should be longer than the radius of the bend. Holes and slots. The correct clearance. Holes and slots can deform if they are too close to a bend. We recommend placing holes at least 2.5 times the material thickness from the bend edges. Slots require more clearance. Place them at least 4 times the material's thickness from the bend edges. In addition, extruding holes or slots is one of the most extreme pressure applications that creates a lot of friction and heat. To avoid deformation or tearing of the metal, place the extruded holes at least 3 times the thickness of the sheet from the edge. Countersinks. Clearance and size. Countersinks are created with a drill press or punch press tooling. The basic rules for countersinks are as follows. Keep a minimum distance of 3 times the material thickness from a bend, 4 times from an edge, 8 times from each other, and they shouldn't be deeper than 0.6 times the material thickness. Curls. The right dimensions. Curled edges are stronger and safer for handling. They are often used to remove a sharp, untreated edge and make it safe. The outside radius of curls must be at least twice the size of the material thickness. If you add holes next to the curls, place them at least the size of the curl radius plus the material thickness from the curls. Other bends should be placed at least 6 times the material thickness plus the radius of the curl from the curls. Hems. The right dimensions. Hems are often used to straighten the edges and make sharp edges safer. Closed hems are not recommended if they are to be painted or the part is made of stainless steel or aluminium. Their flange length from outside the bend should be equal to or greater than 4 times the part thickness. The same flange length to sheet thickness ratio applies for open and teardrop hems. For open hems, the inside diameter should be at least the same size as the material thickness. It will lose its roundness when the inside diameter is greater than the thickness. For teardrop hems, the diameter should also be equal to the material thickness. The hem opening, space between the hem edge and the part, should be at least 1/4 of the sheet metal thickness. Flanges and chamfers. The right dimensions. Flanges are the edge of the part that is bent from the stationary base. It should be at least 4 times the material thickness. If you make a flange with chamfered ends, these chamfers have to leave enough room to achieve proper bends. Tabs and notches. Clearance. Notching is a shearing process that removes a section from the outer edge of the part. Distortion may occur if the distance between the notches and the bend is too small. To avoid this, the notch to bend distance should be at least 3 times the material thickness plus the bend radius. Notches must be at least 3.175 millimeters away from each other. The minimum distance between tabs should be 1 millimeter or the material thickness, whichever is greater. Visit Xometry to get quotes for your parts and order them online. Over 15 production technologies. Over 100 materials. Dozens of finishing options. Get your instant quote at xometry.eu. Xometry, where big ideas are built.